Okay folks, the next three questions, question 2, 3 and 4, dealt with trigonometry. Let's not waste time, let's look at question 2. It says simplify the expression below to a single trig ratio without the use of a calculator. So clearly you've got to use your reduction rules. So let's have a look. We ask ourselves the sine of 180 minus x, which quadrant? It's in the second quadrant, sine is positive, so this reduces to the sine of x. X minus 180, remember you can draw this for yourself. If that's your Cartesian plane, there's x, positive, and because of the minus 180 it means you change direction. 180 in the other direction places it in the third quadrant where tan is positive. So this is the tan of x, simple as that. 90 minus x is in the first quadrant, sine is positive in the first, sine because of the 90 becomes cosine of x. And here those are reduction rules. Here we have an angle. Now we can reduce that to a first quadrant angle by saying this is nothing other than a quadrant, an angle that lies in the second quadrant where cosine is negative. How far is that angle away from the 180 line? Well, it's 70 degrees away, so this is equivalent to minus the cosine of 70. Okay, we leave it at that. Remember, we don't apply our co-ratios immediately. We first reduce all our angles that look like this into first quadrant angles, and then we decide what to do. Okay, we move to the denominator. 90 plus x is second quadrant cosine for centuries and is still negative in the second quadrant. Cosine, because of the 90, becomes minus the sine of x. Then here, minus x is an angle that lies in the fourth quadrant. In the fourth quadrant, tan is negative, so minus tan x. Excuse me. Then the sine of 160, second quadrant, sine is positive, it's 20 degrees away from the horizontal, so this is the sine of 20 degrees. Okay, we have now... Right, now we can decide what to do. We can see we can make our life much easier by getting rid of things at this point. Let's take care of the signs first. A minus times a minus is a positive divided by a negative would leave this with a negative sign. Okay, that has taken care of the positives and negatives, so we don't fall into that trap. The sine of x takes care of sine x. Tan x takes care of tan x. So the only thing I'm left with here is the cosine of x multiplied by the cosine of 70 over the sine of 20. Now cosine and sine are co-ratios, they're complementary ratios, and if their angles are complements, those two things are the same. So the cos of 70 is exactly the same as the sine of 20. I'm saying again, they're complementary angles, the sine, the 70 and the 20. The ratios are complementary, so that is nothing else but 1. So the final reduction brings you to minus the cosine of x. So know your reduction formula. You'll see this is big marks. You can get good marks if you can do these type of questions. Okay, let's look at question 3. Question 3 was asking us to determine the general solution of theta and to write the answer correct to 1 decimal. Okay, so we can start immediately. They've given us that. We can see this is positive, so we immediately apply our definition. 3 theta minus 23 will be the inverse tan of 1,453 plus multiples of the period for tan, which is 90 degrees, and we acknowledge that n can only take on integer values. Okay, so it's a quick one here. I have my second function, tan of 1.453, and that gives me 55,46. Remember, those of you that do AP Maths, to make sure that your calculator is on degrees and not on radians. There, it's a D and not a R. Okay, so on this side I have the 55.46. I collect this angle at the same time, plus 23 degrees, plus then the multiples of 180. Now I don't want to do that all the time, so I'm just going to put a bracket there, a bit of a neater bracket than mine, to show that n is integer. Okay, so this would mean that 3 theta takes on that value. So if I take my calculator, I add 23 to it, I get 78.46, 78.46 plus multiples of 180, and then all I need to do is divide by 3. So theta will be that, 78.46 divided by 3, 26.2 degrees. 26.2 degrees plus multiples of 90. And there's your general solution, a good 4 marks. But folks, you clearly had to know your definition to know what to do with what they've given you. If you don't know your definition, you're going to be stuck. Okay, try and remember these things as far as you can. The next question was question 4, and it asked us to prove an identity. Now remember, again, for identities, the trick is to keep the two sides separately. Now you'll see when you work with trig identities, you do more algebra. In other words, you add, subtract fractions, multiply, divide things, and what you do trigonometry. Let us choose a side. If I look at the two sides, I think I can do the most with the left-hand side. So if I choose the left-hand side, I can see it's 2 fractions that I'm subtracting. Okay, if I subtract 2 fractions, I need an LCD. Folks, please, there's nothing else I could have done here. It is in the simplest ratios. So if I quickly multiply in my head, that's algebra. A minus B, A plus B is A minus B squared. And B was the sine of x. Okay, so I get 1 plus sine x. Now remember, what did I have to multiply that with to get to the LCD? I need to multiply with that. They are the same, so it's a square. Minus, don't fall into a sine trap. That multiplied by that gets me on the LCD, so 1 minus the sine of x, all squared. Okay, so what's left now? If I square this bracket, I get sine squared x plus, it's a normal algebra step. This is algebra, this is also algebra, plus 2 sine x plus 1 minus, keep the bracket so you don't make a silly mistake, sine squared x minus 2 sine x plus 1. And all of that is, don't forget to write your LCD down. I can change this to cosine squared if I'm a little bit lazy. Well, I can do that now because cosine is my answer. Okay, so let's see. Sine squared x minus that sine squared x, there's nothing left. 2 sine x minus times a minus turns that into a plus. So 2 sine x plus 2 sine x gives me 4 sine x. A 1 minus times a plus is a minus, so that turns into a minus 1 plus 1 is nothing. Okay, and this we saw is cosine squared x via the square identity. Okay, so let's see. Where are we now? We need a cosine in the denominator, so I am going to multiply cosine by itself to see what happens there. Cos x times cos x. Now, there's nothing more for me to do at the top. So I have 4 sine x, which in this case I can see is going to be tan. So I get at the top of this fraction 4 tan x. It's all over the cosine of x, which is then my final answer, where I was going to. So the only trigonometry here is this step, is that quotient identity, that sine is, that tan is rather sine over cos. Okay, folks, I hope that helped you.